Using acids and the bases, I'm gonna share the worksheet just now, right now on your screen there. Okay. You tell me when you see it, okay. You tell me when you see it because almost there now. So can you see the worksheet or not yet on your phone there?
I can see it.
You can see it, okay, that's perfect. Alright guys, you're welcome. Now listen, we are beginning acids and the bases, and today is our first video, part 1. And the meaning we're gonna do only definitions, a lot of them before we do our calculations, maybe tomorrow. Okay, so we're talking about acids and the bases. Okay, acids and the what? And the bases. Now these acids, they have been known for quite many years. Okay, but before they were defined in different ways, and then definition came on being updated as time went on. Okay, like the first person to discover acids was called Arrhenius. Okay, so Arrhenius defined an acid in his way, but later on,
Yeah.
hello,
Can you
hello.
please zoom in?
Yes, I'm doing it now. The
And
experiment is
you are
fine.
far.
Okay, how is it now? Is it
It's
fine now?
fine.
Hello? I'm talking about definitions now. I'm here on definitions. Can you see them properly now?
Yes.
Okay, so we are saying that acids and the bases, they have been known for quite many years, okay? But from the
Mm.
beginning, they were discovered by this guy called Arrhenius, okay? And then later, the definition was not sufficient to define all the acids and the bases. So we came up with a better definition of LOWRY and BRONSTED. Okay, so now Arrhenius said that an acid is a substance that produces hydrogen ions when dissolved in water. I repeat, according to Arrhenius, is that an acid is what? Is a substance that produces hydrogen ions when what? When dissolved in water. Okay, let me underline it here for you. An acid, okay, is a substance that produces hydrogen ions when dissolved in what? When dissolved in water. So these hydrogen ions, they give off protons, and so for that case they form the acid, okay? But they must be dissolved in water according to Arrhenius. So if the question says define an acid, according to Arrhenius, you say it is a substance that produces hydrogen ions or hydronium ions when dissolved in water altogether. However, he said that a base is a substance that produces hydroxyl ions when dissolved in water. So, according to Arrhenius, a base is a substance that produces hydroxide or OH ions when dissolved in water. Are we together? So, meaning that according to Arrhenius, only those bases with the OH were called bases. So because of that, the definition could not cater for all the bases in the world. And therefore, we got a better definition from Bronsted and LOWRY. These were two people. They came up with a better definition, which we call the Bronsted-Lowry theory. So the question can say, define an acid using Bronsted-Lowry. I repeat, the question can say define what? An acid using the Bronsted-Lowry. So he said that an acid is a proton or ion donor. An acid is what? An acid is a proton donor. Full stop. I repeat, according to Bronsted and Lowry, what's an acid, guys? Is what? An acid is a proton donor. Anything that can donate proton, they're all about a base. So that a base is a proton acceptor. A base is what? A proton acceptor. So if you can accept protons, then you are a base according to Bronsted and Lowry. Hope we are together. Hello, are we together, Kediboni, so far?
Yes, they're together, sir.
Thank you. Okay, now these acids can be defined in different ways. We've got different types here. Now, if an acid can donate only one proton, then it's called monoprotic. I repeat, if an acid can donate only one proton, it's called referred to as what? Monoprotic. For example, HCl, hydrochloric acid, are we together? As you can see, donating only one proton. Then if an acid can donate 2 protons, we call it what? Diprotic. Okay, like this sulfuric acid here, as you can see, it first of all donates the first proton here, this H, and then later another proton. These are 2 in number, né? So being 2 is called what? Diprotic acid. However, if an acid can donate 3 protons, then we call it what? Triprotic acid. For example, the phosphoric acid donates the first proton here, and again another proton, and another proton. Ne? So they are 3 in number. Ne? So being 3 is called what? A triprotic acid. Hello, are we together?
Yes.
Okay, thank you. Then more to that, we have other definitions which I'm going to talk about as well here. We start with a concentrated versus dilute acid and bases. Okay, so now an acid or a base can be concentrated or can be dilute. I repeat, an acid or a base can be what? It can be concentrated or can be dilute. All together. So concentration is the number of moles of solute per unit volume of solution. I repeat, concentration is the number of moles of solute per unit volume of solution. We can get it using these methods here. You can use the formula which says C equals to N over V. What is our N? Number of moles. What about V? Volume in decimeters cubed. Or you can use C equals to M over MV. Hello, are we together, Kidibone?
Yes.
Okay, we can use C equals to what? M over MV, whereby the first M on top stands for what? The mass in grams. What about this M below? The molar mass, ne? All together. What about V? Volume. Again, what? Decimeters cubed or liters. Okay. Now, this is a definition here. This is how we define this. They can say define an acid which is concentrated. Ne? This is what we say. Okay. So we say that a concentrated acid, okay, a concentrated acid or base contains a large amount, okay, of the acid or base in relation to the volume of water. I repeat, a concentrated acid or base contains a large amount of the acid or base in relation to what? To the volume of water. So the question is going to say, define a concentrated acid. What are you going to say? Say that it is an acid that contains a large amount of moles of the acid in relationship to the volume of water. I repeat, if they say define an acid which is concentrated, you say it is one which contains a large amount of moles of the acid altogether in relationship to the volume of water. Are we together, Kediboni?
Yes.
However, are we together? Ne? Hello, are we together?
Yes.
However, if they say define a dilute acid or a base, this is what we say. We say that a dilute acid, okay, a dilute acid or base altogether contains a small amount of moles of the acid or base in relation to the volume of water. I repeat, we're saying that a dilute acid or a dilute base, it contains a small amount of the acid or base in relation to what? To volume of water. Examples which we have here, we have the strong acid, that's 1 mole per decimeter cubed of HCl. This is concentrated, ne? This is concentrated here. That's 1 mole per what? Per decimeter cubed of HCl. Okay. Then a weak acid we have what? We've got 1 mole per what? Decimeter cubed of ethanoic acid. Now I want you to note that the mineral acids are strong acids. I repeat, the mineral acids, they are what? They are strong acids. For example, sulfuric acid, HCl, nitric acid, those are called the mineral acids, and they are strong acids. Then the organic acids like the carboxylic acids, they are weak acids. For example, ethanoic acid, propanoic, pentanoic, butanoic, all those are what? They are weak acids, including the vinegar. Okay? Then we can have a dilute strong acid. Okay, like in this case we have 0.01 moles per what? Decimeter cubed of HCl. This is now dilute, ne? All together, although it's strong. Then we have a dilute weak acid, for example, what? 0.01 mole of what? Ethanoic acid, ne? So this is dilute and also weak, ne? Okay, now these terms which we are talking about here, you must understand that we defined the one which is concentrated and the one which is what? Dilute, ne? All together. But we also have to also classify them using the strength, ne? All together. Now strong versus weak acid and bases, ne? Okay. So the strength of an acid or a base refers to the ability of the substance to ionize or dissociate. I repeat, if we talk about the strength of an acid altogether, then talk about the ability to do what? To either ionize or dissociate. Let us be specific now. We talk about acids, altogether, an acid. Now, an acid is said to be a strong acid if it will ionize completely in water. So the question will say, define a strong acid. Define what? A strong acid. So we say a strong acid is an acid that what? Ionize completely in water. Are we together? For example, HCl plus water to give us hydronium ion plus chloride ion. Are we together? So the strong acid, like the strong acid, hello, what is to ionize? It means to form ions. It means what? To form the ions, all together. And if we're talking about ionize, look here, look here. It means that we're gonna say HCl plus water. That's when we are ionizing. Hello, I repeat. If we are ionizing, we are forming. You see these ions, we are forming them by this HC reacting with what? Reacting with water. Water now here is a reactant, to form the hydronium ion and the chloride ions, altogether. So this ionizing here. So Kedibone, we are saying that a strong acid is one which does what? Ionize completely in water. Do you see our screen or must I share it again? Hello.
I can see, sir.
Thank you. Now understand that a strong acid gives us a weak conjugate base. We're going to see that shortly. Okay. Now another definition here, if they say define a weak acid, we say that a weak acid will only partially ionize in water. So if they say define a weak acid, you say it is one which only does what? Partially ionizes in water. What does the word mean to you? Partially, it means what? Does not ionize completely, but some part of it ionizes, not all of it. Now, in our equations, if something is partially ionizing, note guys, we use a double arrow. Like this, we use what? A double arrow, meaning we can form the forward reaction and then the reverse. But if it is completely, then we use a single arrow. We use what? A single arrow to show complete ionization, and we use a double arrow to show partial ionization. Are we together? Okay. Let's talk about a base now. So what about a base? Now, a stronger base will dissociate completely in water. The question will say, define a stronger base. Define what? A stronger base. So you say that a stronger base will do what? Will dissociate completely in water. For example, sodium hydroxide. Okay. Now, note the difference. You talk about dissociating. We don't say plus water here in the equation. Like for the sake of ionizing. Now, to dissociate means to split. Yes. It means what? To split the ions into individual ions. So mean that or they were locked up in the base, but now they are being split. they're being dissociated or separated to form the ions in the what? In the water. So a stronger base will do what? Will dissociate completely in water. This is an example here, okay? As you can see, sodium hydroxide dissociating to give us what? Sodium ions plus OH ions in water. Are we together? Note that a stronger base will give us a weak conjugate acid. Okay? Will give us what? A weak conjugate acid. Okay, again about definitions. Now, a weak base will dissociate only partially in water. Okay, and check an example here we have got. By the way, the stronger bases, we have the group 1 bases. What are group 1 bases? Potassium, sodium, lithium. All those are what? Those are group 1 bases. Those are stronger bases. So you see this magnesium is group 2. So it's a weak base because it's only group 1. Okay, so it partially dissociates altogether. Then ammonia is an exception on its own. This ammonia here, you see these other bases, we don't say plus water. Matter with ammonia we say plus water to form the OH ions and ammonium ions. Are we together? Just a little bit, just to take you back a little bit. Check this worksheet again. If you check here, after we're able to call as the conjugate acid base pairs. I'm going to define them now. Okay. Now, if you talk about the conjugate acid base pairs, I want you to know that if you talk about the way the conjugate, we mean potential. We mean something which can be that whatever. Okay. Talk about conjugate base, which means it's a potential base. Altogether, talk about conjugate acid, it's a potential acid. Altogether, now the word potential means it can be that acid, it can be a base. Altogether, look at our example here. We have something saying that an acid, it forms a conjugate base when it donates a proton. Okay, understand that what? An acid forms what? A conjugate base when donates what? A proton. For example, here we have this acid HA giving us A minus plus the proton. Look here, guys, pay attention. You see, this is HN. You see, it contains our H. Contains what? H. But in our product, the H has been given away. It has been donated. It has been done what? Donated. So, because there is no more H here on the A, what it becomes, we call it a conjugate base. We call it what? A conjugate base. So in other words, a conjugate base is formed when an acid donates a proton. Are we together? Then a base forms a conjugate acid when it accepts a proton. Okay, so the base plus a proton gives us what? The conjugate acid. For example, as you see here, here we have our base. It's not a good example here. It's for donating. Okay, I'm going to see an example shortly. Now, conjugates acid and bases differ only by proton. Okay, take an example here, guys. Take an example here. Let us see it properly here. Take an example of nitric acid plus water. Okay, look at the bottle now. Nitric acid plus water. Now, if I have nitric acid, okay, nitric acid, and then I react it with water, okay, water is H2O, okay. Now what's going to happen here? This water is going to act as a base, okay. So it's going to take up a proton to form hydronium ion. To form what? Hydronium ion, okay. And then now the nitric acid, after giving away the proton, is going to become a negative, okay. That's nitrate, okay. It's going to be now NO3 with a minus, okay. All together, pay attention, guys. Here, now you see our HNO3, it is having the proton, but now later it doesn't have it anymore. All together. So because this one donated the proton, we say that's our first acid A1. Did you hear that? I said that HNO3, it has got a proton here. Look at the product now, doesn't have it anymore. Altogether. So because it has donated the proton, it becomes our first acid A1. And after donating the proton, that becomes a conjugate base B1. Okay, are we together? So an acid, after giving away the proton, becomes a conjugate base. Are we together? However, the water, as you can see now, it is H2O, which becomes H3O plus. Now it is accepting a proton. So this water, because of accepting a proton, it is a base. Mara, we have the first base, so it becomes base B2. I repeat, you see the water is H2O here in reactants. What about products? H3O plus, it's accepting a proton. So because of that, it is a base. Because we have the base 1 already, we call it what? Base B2. Now after getting the proton, it becomes a conjugate acid. Acid A2 because we have acid A1 already. I repeat, nitric acid plus water gives us hydronium ion plus a nitrate ion. Are we together? We're saying that nitric acid, because it is giving away the proton, it is called what? Acid A1. Why? Because an acid, according to BRONSTED law, it's called what? A proton donor. Are we together? Now, after donating the proton, it becomes NO3, which you call what? A conjugate base. Called what? A conjugate base. Now, why do I call it conjugate base? I said the way the conjugate means potential, meaning it is a potential base. Now, look here. If I use this arrow, which is facing backwards like this, you see that this nitrate is going to accept a proton from the hydronium to form nitric acid. I repeat, this is called a conjugate base because if I use the reverse reaction, okay, it's going to accept a proton from here to form nitric acid. Hello, are we together? Then because we have our first base here and we see water is accepting a proton, it becomes another base, which you call base B2. Hello? Now this water, after accepting a proton, it becomes a conjugate acid. Don't forget, conjugate means what? Potential. So potential acid, why? Because if I use the reverse arrow, it's going to donate the proton again. Are we together? So in other words, in your test, this is what you do. Because we can ask you the same time, you can say that separate them like this. So this is our acid A1. You draw an arrow, okay, a line like this, acid A1. Then you go to the conjugate base like this. Okay, conjugate base like this. Okay, then you show it like this. So this is A1 and B1, meaning these are acid conjugate base pairs altogether. However, this other one now, again, you can join them together again like this. Now is a different color, I think. I'm using now red. Okay. Now, if I join from here now, you guys can see that the water, this water is now accepting what? The proton. So it becomes what? A conjugate acid. Becomes what? A conjugate acid. All together. Now, this question can be asked in three ways. I repeat, this question, they can answer it how many times? Three ways. They can first of all say, write down the acids in the reaction. Write down what? The acids in the reaction. Write down what? The acids in the reaction. So if we say write down the acids in the reaction, it means your answers, they're going to be A1 and A2. They're going to be what? A1 and A2. Are we together? A1 and the what? And the A2. But if the question says, write down all the bases, what's going to be the answer now? Who can tell us? It's going to be what? B1 and B2. It's going to be what? B1 and B2. Are we together? However, if the question talked about the acid base conjugate pairs, okay? The acid what? Base conjugate pairs. Now, the conjugate pairs, the conjugate pairs Now this is now where you choose. You can choose A1 with the B1, okay, all together, or you can choose A2 with the B2. So don't get lost. Hello, are we together, Kediboni? Hello.
Yes, sir.
Okay, so this question they can ask you, they can ask you that write down the acid from this equation, okay, or they can say write down what the bases from the equation, or they can say write down what the acid conjugate base pairs. Are we together? Then you're gonna say what A1 and B1, or A2 and B2. Are we together? Okay. Are you done writing this, or look, must I wait for you, Kediboni?
I'm done.
Thank you. Let us continue. So that's how we identify what the ACD base pairs. Ne? All right. Now another definition here is called the ampholyte or amphoteric substances. Ne? Okay. Now an ampholyte is a substance that can act as either an acid or a base. I repeat, what's an ampholyte? It is a substance that can act either as what? As an acid or a base. So if we say define an ampholyte, this is what you must say. Okay? You say it is what? It is a substance that can act either as an acid or a base. Are we together? That's an ampholyte. Okay. Now ampholytes, or we also call them amphiprotic substances, they can therefore either donate or accept a proton. So the common ampholytes include the following. We have water. This is water, one of them. Then hydrogen carbonate, hydrogen sulfate. Okay. These are all what? Ampholytes. For example, hydrogen sulfate as an ampholyte. If you look at our equation, you see here that it can react with the water to donate the added remaining proton to form the sulfate with hydronium ion altogether. However, it can also act as a base by taking hydrogen from the water to form sulfuric acid plus OH ions. I repeat, you see this hydrogen sulfate. Why we call it ampholyte? Because it can act as what? As a base or acid. For the sake of the acid, after reacting it with the water, it's going to donate another proton. To remain only SO4 2 minus plus what? Hydronium ion. Altogether, here it is an acid. Altogether, an acid. But now in here, it's accepting what? A proton from the water to form what? Sulfuric acid plus OH ions. So it's acting as a base. So that's why this one is called what? An ampholyte. Hello, are we together? Okay, let us proceed. Let us proceed. Let us proceed. Let us proceed. Anybody with any question? All we are together. Okay. Now here we have the influence of acid and base strength. Okay. Now note that during reaction rates increase as the strength of the acid or base increases. So I want you to know that if the acid is very strong or base, then our rate is gonna be what? It's going to increase for that reaction. Altogether. And then the stronger acid, it means what? A higher concentration of the ions, also leading to what? To greater rate of the reaction. Altogether. Also regarding conductivity, conductivity increases as what? The strength of the acid or base increases. Meaning what? The stronger acid leads to why? To the higher concentration of the protons, leading to what? To a greater conductivity. So note that the stronger the acid, the greater the conductivity. Okay, so these are the common acids which you guys must know. You must know how to write their formulas as well. Number one, hydrochloric acid, all together. Then what? Nitric acid and sulfuric acid. These are strong what? These are strong acids. As you see, these are what? Strong acids. Then for the bases, we have sodium hydroxide and the potassium hydroxide. These are stronger bases all together. And then For the weak acids, we have oxalic acid, hydrofluoric acid, sulfurous acid, carbonic acid, acetic or ethanoic acid, and the phosphoric acid. And then for the weak bases, we have sodium hydrogen carbonate, calcium carbonate, and sodium carbonate, and ammonia. Now these are the weak bases. Okay, let us proceed. Let's talk about the pH scale. The pH scale here. Now the pH scale. Now the pH of a solution is the number that represents the acidity or alkalinity of a solution. I repeat, the pH scale is what? It is a number that shows us what? The alkalinity or acidity of a solution. So the pH is what? It is a number, okay, that represents what? The acidity or alkalinity of a solution. Are we together? Now note that the greater the concentration of hydrogen ions in solution, the more acidic the solution and the lower the pH. I repeat, there's a note here, note that the greater, okay, the concentration of hydrogen ions in solution, the more the acidic the solution and the lower the pH. Are we together? And then the lower the concentration, okay, the lower the concentration of hydrogen ions in a solution, note that it means the more alkali the solution and the higher the pH. And the what? The higher the pH. Okay. All right. Now the pH scale is a range from 0 to 14 and is a measure of the what? The hydrogen ion concentration at what? 25 degrees Celsius in water. Now we have got a formula. We're going to see the calculations. Our pH is given by what? By negative log of what? Hydronium ion concentration, okay? That's H3O plus, okay? Let's put it here. Negative log of what? Hydronium ion concentration. Okay. Are we together? Okay, now we have got our scale here. This side is strong. Okay, put it properly here. As you can see here, we have 0, 1, 2. Ne? You see this? Ne? Now at 70 is neutral. Ne? Altogether, these are acids. These are bases. Ne? Now note that the lower the pH, the stronger the acid, and the higher the pH, the stronger the base. Are we together? Meaning that the bases which are closer to 7, they are weak. Are we together? And then the acids which are closer to 7 are also what? Also weak. Then the acids which are closer to 0, the strong acids. What about what's closer to 14? The strong bases. Are we together? Okay, that's that there. All right, we have our acid reactions here, and then hydrolysis of the salt, and then also the indicators. Okay, now for today we are going to stop here. This was just introducing acids and the bases. I will see you again in our next video. Thank you so much for watching. Bye bye. Welcome. You're welcome.